Hello everyone, welcome back to our channel. In today's video, we will be discussing about parabola. Okay? But before that, if you are new to my channel, please don't forget to subscribe and click the notification bell so you will get notified for the new videos that I'm going to upload. So, this video lesson, we will be discussing about parabola, and we're going to start with the derivation of the formula of the standard form of the parabola when the when the axis of symmetry is vertical as well as horizontal. So, let's get started. Okay, hello everyone, welcome back to our channel. In today's video, we will have the next lesson under our subject pre-calculus entitled parabola. So this is still part 1. So let's start with the definition of parabola. So a parabola is a set of all points, point x and y, or ordered pairs x, y, that are equidistant from a fixed line called directrix and a fixed point called focus not on the line. And the midpoint between the focus and the directrix is called the vertex, and the line passing through the focus and the vertex is called the axis of symmetry. X is equal to h. So take a look at this Cartesian plane. So this is the Cartesian plane. This is your y-axis and this is your x-axis. Okay. Take a look at that curve. So this is an example of a parabola. So this one here is the vertex, which has an ordered pair hk. Okay. So along that line, that is the vertex, y is equal to k. Okay, the vertex is tangent to the line y is equal to k. Okay, so this point is the focus. This is the focus. The ordered pair, which is an ordered pair of h, k plus c. Okay, the distance from here to this side is c. Other books use A or use P. So in this video, we will be using C as the length from the vertex to the focus. And of course, this is H, because remember the x coordinate is H, so that's why it's H. Okay, and since this is K plus C, meaning the length from the vertex towards the focus denotes C, distance C. Okay, so later on you will also understand that this is what we call the latus rectum, and this will be discussed further in our second video. So in this case, we will just start with a basic one. So this is y is equal to k plus c. So this line is y is equal to k plus c. Okay, and toward this point, this is now our directrix, which has a point from the vertex, meaning from the vertex to the focus is equal to, or the length from the vertex to the directrix. And the ordered pair would be k minus c. And this is our directrix now, which is y is equal to k minus c. Okay, so this is just simply an example of a parabola wherein the axis of symmetry is vertical and opens upward. Okay, so this is now the axis of symmetry, which is x is equal to h. Why is it x is equal to h? Remember, our value of our x here is h, and since this is vertical, so the equation of the line of this axis of symmetry is x is equal to h. Okay, I hope you understand the diagram so far. Now let's proceed. Okay. So after which, we have here point 1, for example. Then from the focus to point 1, we have this distance 1 or d sub 1. And we also have the distance from point 1 to the directrix, which is perpendicular to the directrix. So you have this d sub 1. So let's have point 2. So from the focus to point 2, we will have distance sub 2 or d sub 2. Then from the point to the directrix, we have d sub 2. Okay, let's try point 3. We have from the focus to the point 3, we have d sub 3. Then we also have point 3 to the directrix is d sub 3, and we have here perpendicular. This line is perpendicular to the directrix. As you've noticed, there's a symbol that this is a right angle here. Okay, so if you've noticed, d sub 1 must be equal to d sub 1. That's why it's labeled the same. So this is the point now, or by definition of the parabola, that the distance is a locus of points wherein the distance from the focus to any points and the distance from that particular point to the directrix perpendicular to the directrix are equal. So this distance here, d sub 1, is equal to the distance from this point towards the directrix. Same is true with the d sub 2, from focus to point 2 is equidistant to d sub 2 here, from point 2 to the directrix. Okay, same is true with d sub 3. Focus to point 3 is the same length from point 3 to the directrix. Okay, I hope you're able to get the concept now. Okay, so the derivation of the formula where the axis of symmetry is vertical, x is equal to h. It would be better for us to understand how the formula has been derived. Okay, so we will derive the formula or the standard form of an equation for parabola having the vertex hk. So considering this is our focus, again this is our focus with the ordered pair hk plus c, and this is our point xy. Okay, so you have a broken line connecting the focus to that point. We are going to label that one as pf. And we have here point on the directrix. We have d x k minus c. Okay, so you have it here. If you've noticed why it is x k minus c, where did we get this one? Our point is xy. So definitely, since this is perpendicular to the directrix, it follows that this point is x k minus c. Okay, so this line segment, this broken line, we're going to denote as PD. Okay, So this time we are going to derive the formula, the standard form of an equation of a parabola. Okay, but before that, let's start from the beginning. Okay, the distance formula we have, since by the definition, PF is equal to PD. Remember the distance formula that you have used already when we were dealing with solving problems involving circles, wherein we apply the distance formula. But this time, we're not dealing with numbers. There's no numerical value yet, but we have these symbols or variables. We will be using variables. So the square root of x minus h quantity squared. Remember the distance formula. You have the distance formula is x sub 2 minus x sub 1 quantity squared, if you can recall, plus y sub 2 minus y sub 1 quantity squared. So the square root of x minus h quantity squared plus y minus k plus c quantity squared, that is actually following the distance formula, is equal to the square root of x minus x quantity squared plus y minus k minus c quantity squared. Okay? Then, we're going to copy x minus h quantity squared plus y minus, so this one, we are going to expand k plus c. You can have it this way. This becomes y squared. Considering this is the first term and this is the second term inside the parentheses, so you can have this, you can present it in this manner. Square the first term, you have y squared. Then twice the product of the first and the second term, you have k plus c is then 2 times y, that is 2y times k plus c, plus square the last term, you have k plus c quantity squared, is equal to the square root of x minus x is 0. You write 0. The same procedure. This is the square of a binomial. Square the first term, you have y squared, twice the product of the first and the second term. Again, our first term is y, our second term is k minus c, so that becomes 2y times k minus c. Then square the last term, you have k minus c quantity squared. Okay, let's continue. We're going to extract square root both sides of the equation. Now the square root symbol is now eliminated, so we left x minus h quantity squared plus y squared minus 2y times the quantity of k plus c plus k plus c quantity squared is equal to y squared minus 2y times k minus c plus k minus c quantity squared. Okay, let's continue. So we have here the quantity of x minus h squared minus 2ky, because you have to multiply to negative 2y times k, you have negative 2ky, negative 2y times c, that's negative 2cy, plus, okay, squaring a binomial, this is your first term, this is your second term, square the first term, you have k squared, twice the product of the first and the second term, you have 2kc, plus square the last term, c squared. Okay, is equal to negative 2ky, that is negative 2y times k, negative 2ky, then negative 2y times negative c, that's plus 2cy, then copy k minus c quantity squared, we're going to expand this one, so square the first term, which is k, that's k squared, twice the product of the first and the second term, that is negative 2kc, square the last term, that is plus c squared. Okay, now we have here y squared here, and we also have y squared on the other side of the equation. If we are going to transpose y squared here, that becomes y squared minus y squared, so just simply cancel that out. Okay, so what remains is x minus h quantity squared minus 2cy plus 2kc Okay, we have similar terms also. So negative 2ky here and negative 2ky here will be cancelled out. K squared here and also k squared on the other side will be cancelled out. Then c squared and c squared also will be cancelled out. So we will just rewrite what remains. So the remaining terms would be x minus h quantity squared minus 2cy plus 2kc is equal to 2cy minus 2kc. Okay, let's continue. So we have it here. Again, that's x minus h quantity squared minus 2cy plus 2kc is equal to 2cy minus 2kc. So the quantity of x minus h squared is equal to, we're going to transpose negative 2cy and plus 2cy on the other side of the equation. It becomes positive 2cy plus 2cy. We just arrange, like write the terms with the same literal coefficient. Then minus 2kc, copy minus 2kc. Okay. So we have x minus h quantity squared is equal to 2cy plus 2cy, that's 4cy. Then negative 2kc minus 2kc, that's negative 4kc. Okay, so let's continue. Copy x minus h quantity squared is equal to 4cy minus k. Okay. Finally, we're able to derive the formula now. So we come up with x minus h quantity squared is equal to positive c times 4y minus k. Okay. Again, as I've told you, it says here positive c because this is for c. Meaning, c must have a value of a positive number. So, this is now the standard form of an equation of a parabola wherein the axis of symmetry is vertical and facing upward. So you have x minus h quantity squared is equal to 4c times the quantity of y minus k. Okay, again, using the distance formula, that's the reason how we were able to derive this standard form. Okay, let us proceed. Now, note if c is greater than 0, the parabola opens upward. Okay, otherwise, if c is less than 0 or negative, the parabola opens downward. Okay, how about this one? Let's try. So y is equal to k plus c. This would be our directrix. Always remember. Okay, let's have the derivation of the formula. Where the axis of symmetry is vertical, we have x is equal to h. But this time, okay, this time the focus, the opening of the parabola is downward. So always remember the focus is always inside the parabola and the directrix is always outside the parabola. Okay, now considering this one, you have the focus is f, h, the ordered pair hk minus c, the vertex is hk, and of course the directrix would be hk plus c. Okay, and the directrix has an equation y is equal to k plus c. So we have the point xy, this one, point xy, and then going to the focus, we will have pf. This is just simply the same procedure as the first way of deriving the formula. And then we will have point here towards the directrix, perpendicular to the directrix. We say perpendicular, it forms a 90-degree angle. So from point, this point P, towards the directrix, we come up with the coordinates of the point along the directrix, x, k plus c. Okay. So we were going to denote that as PD. Okay. Now, by distance formula, we have, again, by the way, you can interchange where is your x sub 1. If this is your x sub 1, this will be your y sub 1. If this is your x sub 2, this will be automatically your y sub 2. Okay? Or you can do it vice versa. You can have this one as your x sub 1, this is your y sub 1, or this is your x sub 2 and y sub 2. You will get the same result. Okay. So, going back to the distance formula, you have PF is equal to PD by definition of parabola. So, the square root of x minus h quantity squared plus y minus k minus c quantity squared is equal to x minus x quantity squared plus y minus k plus c quantity squared. Then, the square root of x minus h quantity squared plus y squared minus 2y times k minus c plus k minus c quantity squared is equal to the square root of 0 plus y squared minus 2y times k plus c plus k plus c quantity squared. Then, next would be x minus h quantity squared plus y squared minus 2y times the quantity of k minus c plus k minus c quantity squared is equal to y squared minus 2y times k plus c plus the quantity of k plus c quantity squared. Okay, again, the same procedure. If you have the same term here and that with the other side of the equation, you just simply cancel that out. So y squared can be cancelled out. Okay, so now we have x minus h quantity squared minus 2ky plus 2cy plus k squared minus 2kc plus c squared is equal to negative 2ky minus 2cy plus k squared plus 2kc plus c squared. Okay, negative 2ky here, we also have negative 2ky, that will be cancelled out. K squared here, we also have positive k squared, that will be cancelled out. And the c squared here as well as the c squared there can be cancelled out. And rewriting the terms that remain, we have x minus h quantity squared plus 2cy minus 2kc is equal to negative 2cy plus 2kc. Okay, so to continue, we have here, we are going to transpose positive 2cy minus 2kc to the other side of the equation, then write it beside the same term or like terms. So, x minus h quantity squared is equal to negative 2cy minus 2cy plus 2kc plus 2kc. So, that will be x minus h quantity squared is equal to negative 4cy plus 4kc. Then x minus h quantity squared is equal to negative 4c times y minus k. Okay. So we have here okay. So the negative 4c, you might be wondering why it becomes y minus k. Because remember, if you're going to multiply negative 4c times negative k, that is positive 4kc. That will go back to the original binomial here on top. So, we have here x minus h quantity squared is equal to the negative c times 4 times the quantity of y minus k. So, note, if c is less than 0, the parabola opens downward. So, this is the proof that since we are using or we are deriving the formula of the parabola that opens downward, we already were able to see that the value of our c here is negative. Okay, so always remember, every time the value of c is negative, the parabola opens downward. That is if the axis of symmetry is vertical. Okay. Summary of formula. The standard equation of the parabola with vertical axis of symmetry where c is not equal to 0 is given by x minus h quantity squared is equal to 4c times y minus k. And the parabola opens upward if c is greater than 0 and downward if c is less than 0. Then the key points, the vertex is always hk, the focus is always hk plus c, regardless of the value of the c here. The directrix is y is equal to k minus c. And the axis of symmetry is x is equal to h. Okay. This is what you're going to use if we are having this standard equation. If the axis of symmetry is vertical. Okay. The standard form of the equation of a parabola with vertex at the origin. So if the vertex is the origin, meaning h and k is equal to 0, the focus would be 0c, and the equation will be x squared is equal to 4cy, and the parabola opens upward. If the focus is 0, negative c, the equation would be x squared is equal to negative 4cy, and the parabola opens downward. If the focus is c0, the equation is y squared minus is equal to 4cx, and the parabola opens to the right. Then if the focus is negative c0, the equation is y squared is equal to negative 4cx, and the parabola opens to the left. So the summary of the formula, standard form of the equation of a parabola with vertex at hk. So here, parabola opens upward. This is the equation. X minus h quantity squared is equal to 4c times the quantity of y minus k. The focus will be h and k plus positive c. Okay, because that's upward, meaning the value of c is positive. And the directrix will be k minus c, positive c. If it is downward, the equation would be x minus h quantity squared is equal to negative 4c times y minus k, and then the focus will be h, k plus negative c, and the directrix would be y is equal to k minus negative c. If it's to the right, opens to the right, if the parabola opens to the right, this would be the equation y minus k quantity squared is equal to 4c times the quantity of x minus h. So it's just you just swap the formula here, meaning the one that is enclosed in parentheses. And the focus is h plus c, then k. The directrix is x is equal to h minus c. And the parabola opens to the left. The equation is y minus k quantity squared is equal to negative 4c times the quantity of x minus h. Okay? The focus is h plus the quantity of negative c plus k. Then, the directrix would be x is equal to h minus negative c. Okay. So, this will actually guide you on graphing or finding the focus, directrix, equation, and even graphing the parabola. And to tell whether if the parabola opens downward, upward, to the right, or to the left. Okay, so the general form. Let's proceed to the general form. If the squares in any of the equations are expanded and similar terms combined, we obtain the following forms. For the vertical, if the axis is vertical, this is the equation. X squared plus dx plus ey plus f is equal to 0, where e is not equal to 0. If the axis is horizontal, This is now the equation. Y squared plus dx plus ey plus f is equal to 0, where d is not equal to 0. Okay. Thus, the general form of the equation of the parabola with horizontal or vertical axis of symmetry is given by, okay, you have it here. This is the general form of the equation of the parabola with horizontal or vertical axis of symmetry is given by, so this is actually the combination of these two. So that would be ax squared plus cy squared plus dx plus ey plus f equals 0. Okay, so where exactly one of A or C is 0. Why is this so? Where exactly one of A or C is 0. So A or C must, either of these two must be equal to 0. Okay, so when C is equal to 0, then the axis of symmetry is vertical. Remember, if it's x that has a squared that follows the x minus h quantity squared. So that's why the axis of symmetry is vertical. And the parabola opens upward or downward, regardless of the value of your C. The C, which is the distance between the vertex to the focus. When A is equal to 0, then the axis of symmetry is horizontal, and the parabola opens to the left or to the right. Now, let's have an example. Determine the vertex, focus, directrix, and axis of symmetry of the parabola. Y is equal to 1/8 x squared minus 1/2 x plus 7 over 2. Then sketch the parabola and include these points and lines. Determine also its domain and range. Okay, how are we going to solve this one? Okay, so we observe that this is now the given equation. Y is equal to 1/8 x squared minus 1/2 x plus 7 over 2. So, in this example, if you multiply both sides by 8, which is the LCD of the denominator, so this is the LCD of 8, 2, and 2, the LCD is 8. So we observe that, okay, multiply 8 of in all the terms, both left and the right side of the equation. So 8 times y, you have 8y. Then 8 times 1/8 x squared, that is x squared. Then 8 times negative 1/2 x, that's negative 4x. Then 8 times 7/2, that is 28. Why 28? That is 8 times 7, that's 56, and divided by 2, that is 28. Afterwards, equivalently, by the way, the value of C here is 0. Then we have here, we are going to arrange it according to the general form. We have x squared minus 4x minus 8y plus 28 is equal to 0. Now, you've noticed that the value of C here is 0. C is supposed to be the numerical value of y squared. Okay? So, if the value of C is 0, then the axis of symmetry is vertical. And the parabola opens upward or downward. We don't know yet if it opens downward or upward or downward, but we're already very certain that the axis of symmetry is vertical because the value of C, which is supposed to be cy squared, is 0. Okay? So the relation here is a function, by the way. So, let's continue. So, why is it the relation is a function? Because the parabola opens upward or downward. The graph or that kind of relation is always a function because using the vertical line test, it will only intersect at most one point. Okay. So, so going back to the general form of equation, for ax squared plus cy squared plus dx plus ey plus f is equal to 0. And we're going to compare the resulting equation, x squared, so you write it here. our cy is unknown. Cy squared, we don't have y squared here. Then with the x variable, we have negative 4x, and our ey is negative 8y, and then our f is constant, we have 28. So the value of c is 0 again, so the axis of symmetry is vertical, and the parabola opens upward or downward. Okay, continue. So we already have the solution. This one, since we come up with this already, so this is the original equation given, then we multiply both sides by the LCD of the denominators. We come up with this one after multiplying both sides by the LCD of the denominators. Then we come up with the symmetric property or the general form. We come up with the general form a while ago, and this time we do like this one, so we will go back to the standard form later on. Okay, so the x squared minus 4x plus 28. Okay, after this one, we're going to have it in this way. X squared minus 4x plus 28 is equal to 8y. Symmetric property, we just simply interchange the right and the left side of the equation. So no need to change the signs of the terms. If all the terms at the left and the right, we just simply swap or interchange. Is equal to 8y. Then afterwards, all x variables will be placed on the right side, and all the y variable together with the constant will be left on the right side. So we have here x squared minus 4x is equal to 8y minus 28. Okay, let's continue. Okay. So we have here x squared minus 4x is equal to 8y minus 28. By completing the square, you know already how to complete the square. So you have x squared minus 4x plus 4. Okay, this is how you're going to complete the square. Divide to get half of negative 4, which is negative 2. Square negative 2, that is positive 4. And whatever you add on this side, you will also add on the right side. So that becomes x squared minus 4x plus 4 and 8y minus 28 plus 4. Then, next would be, this is already a perfect square trinomial. So, it is already equivalent to x minus 2 quantity squared. This is the factored form. Copy 8y. Negative 28 plus 4 is negative 24. So, factor out the left side of the equation. Copy this one again. So, you have 8. Then, for 8y minus 24, 8 is actually the greatest common monomial factor. So, 8y divided by 8 is y. Negative 24 divided by 8 is negative 3. Okay, let's continue. Okay, so I hope that you were able to understand the procedure from the very beginning. Okay, so since you have here 8x minus 2 quantity squared is equal to 8 times the quantity of y minus 3, let's get the value of c. Remember that for c, remember the formula. So this will be 4c. So 4c is equal to 8. Therefore, we have, since 4c is equal to 8, then divide both sides by 4. C is equal to 2. You've noticed that c is positive 2. It means that the parabola opens upward, because we know already that the axis of symmetry is vertical. Then the vertex is positive 2 and positive 3. Remember, that is hk, x minus h and y minus k. Then to get the focus, remember the focus is h, k plus c. So our h is 2, just copy 2, and then our k is 3, then plus the resulting value of c, which is 2. So that is 3 plus 2, the focus is 2, 5. Then the directrix, the formula for the directrix, you have y is equal to k minus c. So our k is 3, our c is 2. So that becomes 3 minus 2, our directrix is y is equal to 1. And then the axis of symmetry is x is equal to h. Our h is 2. Our h is 2, therefore our axis of symmetry is x is equal to 2. Okay. So I hope that it's clear so far. And there's actually an alternative formula for C. So we'll just introduce this with you because some books or some resources will give you this one. You might be encountering this alternative formula to find the value of C. So from the standard equation of the parabola, x minus h quantity squared is equal to 4c times the quantity of y minus k, we have x minus h quantity squared is equal to 4c times y minus k. Then 4c is equal to y minus k is equal to x minus h quantity squared. We just simply swap symmetric property. Then we just simply divide both sides by y minus k, 4 times y minus k. So c will remain on the left side of the equation. So this is actually how to solve for c if you have these values. If you have the value of your x, you have the value of your y. Remember, x and y are point on the parabola, and hk are actually the vertex. Okay. So note, set x is equal to 0 to solve for the value of y, then substitute the value of h and k. Okay. So we will have, remember, this is the original form or original equation given. So y is equal to 1/8 x squared minus 1/2 x plus 7 over 2. If we're going to let x 0, we can solve for the value of y. So 1/8 times 0 squared minus 1/2 times 0 plus 7 over 2. So this will be 0, and negative 1/2 times 0 is 0. So y will be 7 over 2. Okay. So if x is 0, y is 7 over 2. So we are going to substitute the value of our x and y. So our x and y, so we will have, okay, so c is equal to x minus h quantity squared over 4 times y minus k. So our x, because we let x is 0, then minus our h, the value of our h is 2, then quantity squared over copy 4, then our y, the resulting value of our y when x is 0 is 7 over 2. So we write 7 over 2. Then copy minus 3. 3 is given. Again, x, hk is given. Our vertex is given. Then 0 minus 2 quantity squared is 4. Then you have 4. 7 over 2 minus 3. 7 over 2 minus 3 is 1/2. Then we'll have times 4. That is 4 times 1/2 is 2. Therefore, c is equal to 4 over 2. c is equal to 2. So the same result in finding the value of c. So preparing the graph of y is equal to 1/8 x squared minus 1/2 x plus 7 over 2. So the y-intercept, to solve the y-intercept, we set x is equal to 0, then solve for y. Since the equation is already in the form of y is equal to ax squared plus bx plus c, the value of c is the y-intercept. Okay, the value of c is automatic, the y-intercept. Thus, the y-intercept is 7/2. So the x-intercept, to solve the x-intercept, we set y equals 0, then solve for x. So the solution would be y is equal to 1/8 x squared minus 1/2 x plus 7/2. So you are going to let y, or set y equals 0, then copy 1/8 x squared minus 1/2 x plus 7/2. Then preparing the graph of y is equal to 1/8 x squared minus 1/2 x plus 7/2, the x-intercept, okay, so you have 1/8 x squared minus 1/2 x plus 7/2 equals 0, then multiplied 8, both sides of the equation, so we'll have 8 times 1/8 x squared is x squared, 8 times negative 1/2 x is negative 4x, 8 times 7/2 is positive 28, then 8 times 0 is 0. Then copy x squared minus 4x is equal to negative 28. So this time, you're going to complete the square. Completing the square, you have x squared minus 4x plus 4, and the negative 28, whatever you added here, you will also add in this side. So that becomes x squared minus 4x plus 4 is equal to negative 28 plus 4. Then the quantity of x minus 2 squared is equal to negative 24. X minus 2 squared is equal to negative 24. Then x minus 2 is equal to the square root of negative 24. X minus 2 is equal to plus and minus square root of negative 24. Then you will have x is equal to plus and minus square root of negative 24 plus 2. X is equal to plus and minus square root of 24 times negative 1 plus 2. Remember, the square root of negative 1 is an imaginary number, and it is symbolized as a small letter I. That's why we have here small letter I. Okay? So x is equal to plus and minus 2i square root of 6. So remember, 24 can be factored out by 4 times 6, wherein 4 is a perfect square, and square root of 4 is 2. That is why 2 is outside, and you retain 6 inside the radical symbol, plus 6. Okay, so our x sub 1 will be 2 plus 2i square root of 6. Our x sub 2 will be 2 minus 2i square root of 6. Okay. Okay, so let's continue. Okay, I hope that everything is clear so far. Okay, so you can have that one. Note that the x-intercepts are imaginary numbers, so this will not pass our x-axis. So once it's imaginary, it will not pass or intersect our x-axis. So this is what will gonna happen. So this is now the graph. So we have here the vertex. This is the point. 4, 7, 2, then 8, 15, 2. This is the vertex 2, 3, and this is the focus 2, 5, and this is the directrix 2, 1. So we have here the axis of symmetry is vertical, x is equal to 2, and the point of the directrix here is 2, 1. Okay. So you have here d sub 1 is equivalent to d sub 1 here, and d sub 2 is equivalent to d sub 2 along the directrix. So this is y is equal to 1. As you've noticed, the domain would be the set of all x's such that x is an element of all real numbers, because the parabola opens upward, the axis of symmetry is vertical, and the arrowheads on both directions. There's arrowheads both directions. So the domain or the set of all x's will be the element of all real numbers, and the range would be the set of all y such that y is greater than or equal to 3. This is our minimum value. This is y is equal to 3. There's no way that the parabola will go down. This is already the orientation of the parabola. It goes up or opens upward. So the range would be the set of all y such that y is greater than or equal to 3. Okay, so I hope that you were able to follow the steps from the very beginning. Okay, let's continue. Now, this time, we will have a collaboration. Choose a partner to work on this problem below. So, you already have a partner. The previous partner that you have, you are going to follow the same procedure. You're going to show the solution. I will provide the answer, but you have to show the solution. Okay? So, determine the vertex, focus, directrix, and axis of symmetry of the parabola. Y is equal to negative 1/4 x squared minus 3/2x plus 11/4. Then sketch the parabola and include these points and lines. Then determine also its domain and range. Okay, so the answer of the collaborative work will be this one. By the way, so I didn't provide you, I'll just want you to answer by pair with this one. So there's no answer. So you are going to show your solution, of course, with the answer. Then, let's have the individual tasks. Find the directrix, axis of symmetry, and the standard form of the equation of the parabola with vertex 1, 2, and focus 1, -1. Sketch the parabola and include these points and lines. Determine also its domain and range. So the answer to the assigned task would be this one. Okay, so I want you to answer this one under performance task by pair. Though I said that this is individual task, but I will just let you answer it again with your partner. Okay, it will be easier for you. The more students, I've noticed that you were able to understand if you're gonna discuss it with a partner. So find the directrix, axis of symmetry, and the standard form of the equation of the parabola with vertex 1, 2, and focus 1, -1. Then sketch the parabola and include its points and lines. Then determine also its domain and range. Again, though it's individual tasks, but just use the same partner or by pair. So this is now the answer. I'll provide the answer on the individual task, but you have to show your solution. Okay? You really have to show your solution. Okay, so this is now the answer. Okay. Okay, let's continue. Okay. And that is the domain and the range for the individual tasks. Okay. Now let us proceed to the parabola that opens to the right and to the left. Okay, so this is our vertex HK. That is x minus h along x minus h. That is our focus, h plus c, then k. Along with that line, x is equal to h plus c. Then, the line of the directrix is from point DH minus CK, you have x is equal to h minus c. Then, we have the axis of symmetry. Axis of symmetry is horizontal this time. That is y is equal to k. Okay, so that's axis of symmetry. Now, let's proceed to the derivation of the formula where the axis of symmetry is horizontal. Y is equal to k. Okay, considering we have point from the focus to the point P, x, y, to the point along the directrix h minus c, y, perpendicular to the directrix. So we have that right angle here. So we'll continue. So we have PF Okay, we're going to denote this as PF, line PF, and line PD. Then we're going to equate the equation, equate using the distance formula, the same formula that we used a while ago during with the axis of symmetry that is vertical. Okay, so PF is equal to PD, the square root of, you have here the quantity of x minus h plus c quantity squared plus y minus k quantity squared is equal to the square root of x minus h minus c quantity squared plus y minus y quantity squared. Then the square root of x squared minus 2x times h plus c quantity squared plus y minus k quantity squared is equal to the square root of x squared minus 2x times h minus c plus h minus c quantity squared plus 0. Then x squared minus, extract square root both sides of the equation, so the square root symbol will be eliminated. Then x squared, just copy, minus 2x, copy h plus c, then plus h plus c quantity squared plus y minus k quantity squared is equal to x squared minus 2x times h minus c plus h minus c quantity squared. Next, we are going to, okay, we have x squared here, we also have x squared here. We're going to cancel that out. Okay, then we also have negative 2hx here. We also have negative 2hx. We are going to cancel that out. Then h squared here as well as h squared here, we're going to cancel that. Then the c squared here and also the c squared, cancel that out. Then we are going to write the remaining terms. Negative 2cx plus 2hc is equal to negative 2cx minus 2hc. Okay, of course, you still have remaining plus y minus k quantity squared, this one. That is supposed to be here, this one. This is a continuation. Okay, so we have here now negative 2cx plus 2hc plus y minus k quantity squared is equal to 2cx is minus 2hc. Then y minus k quantity squared is equal to 2cx plus 2cx minus 2hc minus 2hc. Meaning we transpose this, negative 2cx, that becomes positive 2cx. And 2hc becomes negative 2hc. Then just arrange it. Just write it beside the term. Then y minus k quantity squared is equal to 4cx. Then negative 2hc minus 2hc, we have negative 4hc. Then y minus k quantity squared is equal to 4c. Then you have x minus h. Then y minus k quantity squared is equal to, you have 4c x minus h. Since it's 4c, automatic, our c is positive. Okay, so note, if c is greater than 0, the parabola opens to the right. Okay? So the derivation of the formula where the axis of symmetry is horizontal, y is equal to k. Now this time, let's try to derive the formula, the standard formula of a parabola when the graph opens to the left and when the axis of symmetry is horizontal. So again, this is our vertex hk. This is our focus h minus c k. This is our directrix h plus c then k. Okay, that is our directrix. The equation of directrix is x is equal to h plus c. So considering we have point P, xy, connecting to the focus, so we label that as PF. Then we have PD. Okay? So by using the distance formula again, we are going to equate. Okay. So this time we have square root of x minus h minus c quantity squared plus y minus k quantity squared is equal to, okay, that's pf is equal to pd, is equal to the square root of x minus h plus c quantity squared plus y minus y quantity squared. Then you have the square root of x squared minus 2x times h minus c plus h minus c quantity squared plus y minus k quantity squared is equal to the square root of x squared minus 2x h plus c squared plus 0. Then x squared minus 2x h minus c quantity squared plus y minus k quantity squared is equal to x squared minus 2x times h plus c quantity squared. So x squared here and x squared here will be cancelled out. So negative hx and negative 2hx also will be cancelled out. H squared here and also h squared here will be cancelled out. Then c squared and c squared here will be cancelled out. So what retains is 2cx minus 2hc plus y minus k quantity squared is equal to negative 2cx plus 2hc. Okay. Then 2cx minus 2hc plus the quantity of y minus k squared is equal to negative 2cx plus 2hc. Then we have y minus k quantity squared is equal to, okay, you transpose 2cx and minus 2hc to the other side of the equation. Of course, their sign will be changed and write them beside the like terms. So the remaining terms here would be y minus k quantity squared is equal to negative 2cx minus 2cx plus 2hc plus 2hc. Then y minus k quantity squared is equal to negative 4cx. Then 2hc plus 2hc is 4hc. Then y minus k quantity squared is equal to negative 4c times x minus h. Then y minus k quantity squared is equal to negative c times 4 times x minus h. So you've noticed this time the value of our c is negative. Okay. So we have, note, if c is greater than 0, it should be less than 0. If c is less than 0, correction for this one, the parabola opens to the left. Less than 0 because it's negative. Okay, the summary of the formula, the standard equation of the parabola with horizontal axis of symmetry, where c is not equal to 0 is given by y minus k quantity squared is equal to 4c times x minus h. The parabola opens to the right if c is greater than 0 and to the left if c is less than 0. And the key points, vertex hk, the focus is h plus ck, directrix is x is equal to h minus c, the axis of symmetry is y is equal to k, and the value of c, the alternative way of solving for c is y minus k quantity squared over 4x minus h. Okay, so let's have an example. Find the standard form of the equation of the parabola with vertex negative 5, negative 3, and the focus is negative 2, negative 3. Draw its graph and determine the domain and range. So observe the given points for their corresponding y coordinates. Negative 5, negative 3 is the vertex. The focus is negative 2, negative 3. Compare their values of y. Now, since the axis of symmetry is horizontal, where y is equal to k, we consider the equation y minus k quantity squared is equal to 4c x minus h. Always remember, always notice the axis of symmetry. So if that's the vertex and you have the focus, so the axis of symmetry will be horizontal. Okay? If you're going to plot the points. Then the equation, if the axis of symmetry is horizontal, is this one. Y minus k quantity squared is equal to 4c times x minus h. Okay? where h is equal to negative 5, which is given, k is negative 3, which is given, and h plus c is equal to negative 2. Okay, that's our focus. Okay, solve for c by substituting h is equal to negative 5 using the x-coordinate of the focus, h plus c. So h plus c is equal to negative 2. Negative 5 plus c is equal to negative 2. Then c is equal to negative 2 plus 5. Therefore, c is equal to 3. Since c is equal to 3, the parabola opens to the right since c is greater than 0, since c is positive. Okay, now using the standard form where the axis of symmetry of the parabola is horizontal, we have y minus k quantity squared is equal to 4c times x minus h. Then y minus negative 3 quantity squared is equal to 4 times 3 times the quantity of x minus negative 5. Then y plus 3 quantity squared is equal to 12 times x plus 5. Then we will have expand. This becomes y squared plus 6y plus 9 is equal to 12x plus 60. Okay. Then it becomes 12x plus 60. We just simply by symmetry, we'll just simply swap the left and the right side. Swap the terms between the left and the right side of the equation. We have 12x plus 60 is equal to y squared plus 6y plus 9. Then 12x is equal to y squared plus 6y plus 9 minus 60. Then 12x is equal to y squared plus 6y minus 51. Then if this is the case, you will have divide both sides by 12. Okay? So we can have an equation in terms of x. Okay, so you will have x is equal to 1 over 12 y squared plus 6 over 12 y minus 51 over 12. So you will have x is equal to 1 over 12 y squared plus 1 half. 6 over 12 is 1 half y. 51 over 12 can be expressed in simplified into negative 17 over 4. Okay, now to draw the graph of the relation x is equal to 112 y squared plus 1 half y minus 17 over 4. Solve for y in terms of x. Now the reason why we express the equation like this, so we can actually solve for the values of our y, solve for the value of our x in terms of y, or y in terms of x. Okay, solve for y in terms of x. So we'll have x is equal to 1 over 12 y squared plus y 1 half y minus 17 over 4. Then we interchange. Then divide both sides by 12. That is our LCD. Then 12 times 1 over 12 y squared is y squared. 12 times 1 half y, that is 6y. 12 times 17, negative 17 over 4, that is negative 51. And then 12 times x is 12x. Come up with this. Next is, okay, so we have y squared plus 6y minus 51 is equal to 12x. Y squared plus 6y is equal to 12x plus 51. Then y squared plus 6y, we're going to complete the square now. Completing the square, y squared plus 6y plus 9. That is 6 divided by 3, then 3 squared is 9. Then whatever we added on the left side of the equation will also be the same number we are going to add on the right side. So we added 9, we also add 9 here. So this is now a perfect square trinomial. It can be factored as y plus 3 quantity squared. Then is equal to 12x, copy 12x. 51 plus 9 is 60. Then copy y plus 3 is equal to plus and minus square root of 12x plus 60. So y is equal to plus and minus square root of 12x plus 60 minus 3. Okay, because we place 3, we transpose 3 to the other side. So we have this equation solving for y in terms of x. Okay, let's continue. So this is already expressed y in terms of x. So if x is negative 5, this is the approximate value. If x is negative 5, y is negative 3. If x is negative 4, this is the value, and this is the approximate value. If x is negative 3, this is the value. If x is negative 2, and this is y. If x is negative 1, this is y. Okay, so you might be wondering why I didn't show the solution for this, because we're done already. All you have to do here is just simply substitute the value of x here. So if x is negative 5, you write here negative 12 times negative 5 plus 60. Then get the square root, then minus 3. So that will be your value of your y. So the answer is negative 3. Same is true with this one. Okay? So make sure to place plus and minus, because that is positive and negative. This is a parabola. So we'll have 2 values for y for every 1 value of x. Because the axis of symmetry is horizontal. Okay, let's continue. Okay, so this is now the graph. Plotting the points, we're able to solve. And the vertex is negative 5, negative 3. The domain is the set of all. By the way, the domain is the set of all. This is supposed to be x. For a moment, I will make some corrections. Okay, this is okay. The domain is x. For a moment. Draw shapes and then, okay. This is supposed to be, I cannot draw. This is supposed to be x. Okay, and this is, I'm going to write, okay, it should be color yellow. For a moment, please bear with me. This is x. The set of all x's such that x is an element of real numbers that are greater than or equal to negative 5. Okay, so this is the value of our domain. Okay, so negative 5 is included, that's why there's an equal to. Okay, then next, that's our vertex. The axis of symmetry is y is equal to k. That's the point. So this is what I told you. If x is negative 4, our y is positive 2, square root of 3 minus 3. And here also, negative 2 square root of 3 minus 3. So that's why we have 2 values of y. Okay. And our range would be, if this is the case, our range will be a set of all y such that y is an element of all real numbers. Okay. But, okay, let's continue. Now, situational problems involving parabolas. But before that, let's go back to the, okay, there's one that I'm going to make some corrections. So I will just write the correction. It's all about when the parabola opens at this one. Okay, since C is less than, this should be less than. Okay, I want you to make the correction. This should be less than. Okay, then let's proceed. Now this time we are going to have examples of problems involving parabolas. Okay, so I hope everything is clear so far. So you can write your comment if you have questions regarding the flow of the solution. Okay, so we're done. We're able to graph. We're able to plot the points, and I think you have familiarized already how to plot the points on the Cartesian plane. Okay, now situational problems involving parabolas. So let's have the situational problems involving parabolas. Okay, this one. Now a satellite dish has a shape called a paraboloid, where each cross-section is a parabola. Since radio signals parallel to the x-axis will be bounced off the surface of the dish to the focus, the receiver should be placed at the focus. How far should the receiver be from the vertex if the dish is 12 feet across and 4.5 feet deep at the vertex? So this is now the picture of a parabol. Okay, this is the shape of a paraboloid, that one. And this is a satellite dish. Okay, now considering this parabola, if we're going to construct using the given, so we have this one. This is endpoint negative 4.5, and here is 4.5. And the vertex is at 0, 0 with C. So the figure above shows cross-section of the satellite dish drawn on a rectangular coordinate system with the vertex at the origin. Then, since the equation of the axis of symmetry is x is equal to h, we have x minus h quantity squared is equal to 4cy minus k. Since the coordinate of the vertex is at 0, 0, we will have x minus 0 squared, quantity squared, is equal to 4c times y minus 0. Then we'll have x squared is equal to 4cy. Then 6 squared is equal to 4c. Our y is 4.5 because of the point given. Then 6 squared is 36 because we are given also the point 6. You have 36. Then 4c is equal to 4.5. 4 times 4.5 is 18c. C is 36 over 18. Then c is equal to 2. Okay. Thus, the receiver should be 2 feet away from the vertex. So this is as simple as that. Very easy. Another problem. The cable of a suspension bridge hangs in the shape of a parabola. The towers supporting the cable are 400 feet apart and 100 feet high. If the cable at its lowest is 30 feet above the bridge at its midpoint, how high is the cable 50 feet away horizontally from either tower? Okay, this is the photos of a suspension bridge. I think you have seen this one locally. Okay, this is a suspension bridge. Okay, that one. Okay, so a suspension bridge is a type of bridge in which the deck or the load-bearing portion is hung below suspension cables on vertical suspenders. Okay, so as you've noticed, the shape is parabolic. Okay, so we will have it like this. Okay, that is our suspension bridge with a given. The cable in feet at its lowest above the bridge is this one. You have 30 feet. Okay? And this is 200, 150. This is the point. The question is 50 feet away. What is the height of the cable 50 feet away from the tower? Okay, 50 feet away from the tower. This is a tower. 50 feet away from 200 to 150. Okay. So that point. So 150 is our x, but we don't know the height. We don't know the value of our y. So that is unknown. That is what we are going to solve. Okay. So we'll have, since the tower are 150 feet high and 450 feet apart, we deduce from the figure that 200, 150 is a point on the parabola. Thus, kx minus h squared is equal to 4cy minus k. Then 200 minus 0 squared. 200 is the x coordinate, the point, minus 0 quantity squared is equal to 4c. Our y is 150 minus 30. Then 200 squared is equal to 4c. 150 minus 30 is 120. Then 40,000 is equal to 480c. Then 480c is equal to 40,000. C is equal to 40,000 over 480. C is equal to 250 over 3. Then the value of our C, okay, our C is 250 over 3. So we are going to let it as that, leave it as that, since it's not a whole number. Then afterwards, since we come up with our value of C, we're going to go back to our standard form of an equation. We have x minus 0's quantity squared. Since we have the standard is x, formula is x minus h quantity squared is equal to 4c times y minus k. Then x minus 0 quantity squared is equal to 4 times 250 over 3 times y minus 3. Our value of c is 250 over 3. We are here to solve for the value of our okay, later on we can solve for the value of our y. So x squared is equal to 104 times 250, that's 1000 over 3 times y minus 3, just copy. Then x squared is equal to 1000 y over 3 minus 1000 times 30 is 30,000 divided by 3. Then x squared is equal to 1000 y minus 30,000 all over 3. Then cross multiply, we have 3x squared, or multiply both sides by 3. We have 3x squared is equal to 1000 y minus 3000. Then we will have, by the way, this is 30,000, correction. So I'll make some correction. This must be 30,000. Okay, then 1000 y minus minus 30,000 is equal to 3x squared. Then 1000y is equal to 3x squared plus 30,000. This is 30,000, lacking 1 0 here. Okay, then y is equal to 3x squared over 1000 because we divide both sides by 1000 plus 30,000 divided by 1000. So you have y is equal to 3 over 1000 x squared plus 30. So solving for x in terms of y, or solving for y in terms of x. So this is now our equation. So we are now ready to solve for y in terms of x. Okay. So we can now solve for the height. Now y is equal to 3 over 1000 x squared plus 30. Then y is equal to 3 over 1000. So the 22,500, the value of our x. Okay? Remember, our value of our x solving the height of the cable 50 feet away from either tower when x coordinate is 150. So x is 150, 150 squared, that gives us 22,500. Then copy plus 30. Then y is equal to 3 times 22,500 is 67,500 divided by 1,000, then plus 30. Then y is equal to 67.5 plus 30. The value of y is 97.5. Okay. So you have, thus the cable is 97.5 feet high, 50 feet away from either tower. So finally, you were able to solve the height of the cable when it's 50 feet away from either tower. Okay? With an x-coordinate of 150. Now, we will have another last example, a very simple example. So, for example, you are asked to graph the equation, identify the focus and directrix of the parabola. X squared is equal to 2y. So, basically, if this is the equation, the axis of symmetry is vertical and the vertex is 0, 0 or at the origin. Okay? Then our 4P, by the way, P or C is just the same. P or C are just the same. So other books, other resources will use P, while others will use C. And even others use A. So don't be confused with this too. So x squared is equal to 2y. To solve for P or to solve for C, you have 4P is equal to 2, P is equal to 1 half. If P is equal to 1 half, the focus is 0, 1 half here. And the directrix is equal to y is equal to negative 1 half. Following the formula with the standard form, you will have that one. Okay, since you are asked only to find the directrix and the parabola. Okay, so this time I think you are now ready for the assessment. Okay, so on your activity notebook, but before that, you have 2 problems already that you are going to answer by pair, and this one is individual. Okay, write the standard form of an equation for each parabola. Number 1, focus is 0, 6. Directrix is y is equal to negative 6. Number 2, focus is 0, negative 8. Directrix is y is equal to 8. Number 3, focus is negative 2, 0. Directrix is x is equal to 2. Then 4, focus is 3, 0. Directrix is equal to x equals negative 3. Then also identify some key features of the parabola and then graph with this equation. Y is equal to x minus 4 quantity squared minus 6. Find the focus, vertex, axis of symmetry, directrix, and direction of opening. Okay, so I hope that you were able to understand part 1 of the parabola discussion. And before we are going to end this video lesson, let's have a math code. This is from Carl Jung. The curve of life is like the parabola of a projectile which, disturbed from its initial state of rest, rises and then returns to a state of repose, like a projectile flying to its goal. Life ends in death. Even its ascent and its zenith are only steps and means to this goal. For enlightenment or no enlightenment, consciousness or no consciousness, nature prepares itself for death. So that would be all, and thank you so much for watching, and please don't forget to subscribe my channel. Bye!